Every day, we face a number of decisions which seem to need our immediate attention. An easy method to help us select which decisions are most important is a Pareto chart. This is a type of column graph which almost automatically points out the order in which we should make our decisions. Pareto is the name of a European scholar who in the 1800s developed this method to attract attention to the alarmingly narrow distribution of wealth. Since then, it has become a popular decision-making aid in many fields. There are 6 easy steps in the construction of a Pareto chart. To illustrate, we will use the example of a group of defective items. Each item has a tag describing the type of fault, the equipment used to do the work, the employee, and the shift. The first step is to decide which data should be shown on your Pareto chart. A good way to get started is to organize your chart by type of fault. If this does not provide the analysis you need, then try one of the other possibilities. The second step is to specify the time period in which you will collect data. High production items tend to furnish more data in a shorter time. Step 3 is to collect your data on a check sheet. Construct the check sheet to reflect the decision you have already made, the data to be collected, and the time period to collect it. Your completed check sheet should look something like this. It is easy to understand what data has been collected and for how long. This check sheet clearly indicates 70 observations were made during January and February. The fourth step is to construct your Pareto chart from the data you have recorded on your check sheet. You can see that the check sheet is an important step. If it is done correctly, it is a simple matter to select the most frequent fault and use that data to make the left column, then the rest in descending order to the right. Some of the minor faults are grouped in the other column, which always appears on the right. Do you remember how many total faults were listed on our check sheet? That's right, there were 70. Now, if we have reconstructed our Pareto chart correctly, all the columns stacked one on top of the other will form one long column reaching the 70 mark on our graph. For some applications, this may be enough information on which to make a decision, but frequently we must go one stage further and determine the percentage of change between the columns. In step 5, we add the cumulative line called the cum line. A quick glance shows that it ends at the same level as the 70 mark on our chart. Let us see how it got there and what it means. We start the cum line at the lower left or 0 corner and move diagonally to the top right corner of the first column. The top of the line is now at the 22 level. Now repeat the process, adding the 17 represented by the second column, and the line rests on the 39 level. The process is again repeated, this time adding the 14 represented by the third column, and the line now rests on the 53 level. The process is repeated for each column until the line reaches the 70 fault level, which is 100% of the items. Until you complete step 6 by adding a legend to the chart, your effort will have little value to anyone else. Always include information such as who collected the data and when. Add any other information which will make the chart more useful. Some applications are more revealing if the Pareto chart is used to reflect the faults in terms of their cost. When the cost of each fault is considered, we often find a reordering of the fault categories. While transit damage was not as numerous as no instructions, occurrence of transit damage cost more. Therefore, when cost was considered, transit damage became the #1 problem. You remember we learned in step 2 to select one category of data from which to construct our Pareto chart. In the example, we chose to analyze by type of fault, and it worked out well. But it might have looked like this, with no column really standing out as the place to start. In such a case, we must select a different category, such as operations in which the events occurred. Now that doesn't look any better than before. So let us pick another one, and this time let us look at the shift on which the faults were observed. That's more like it. Now we can see some real differences. At this point, we ought to try looking at faults again, this time for only the second shift. We have seen how check sheets help us to construct a Pareto chart. Now we can see how the Pareto chart can lead us right into a cause and effect analysis of the problem we have identified. Another part of the Pareto chart we mentioned earlier is the Coombe line. See how it helps us to quickly find the percentage of each column to the total. By locating each point of the Coombe line on the percentage scale, simple arithmetic gives us our answer. Pareto charts also help us to see the effects of changes when compared side by side. This can be a very impressive way of showing improvements during management presentations. I think we are now ready to look at several practical applications of this very versatile tool. Our attention can be focused on the main problem instead of spread over the many less important ones. A Pareto chart is often a very effective way of getting your message across in a presentation. To keep all employees informed of quality trends by being posted in the work areas. Costly industrial accidents can be reduced by our becoming more aware of how and where they happen. Cutting costs of office operations cannot be done efficiently until we know the costs of the various problems facing the staff. When reviewing the company's product line, a Pareto chart can help us see where most of the production costs are going and where the income is coming from.